Slab lifting with polyurethane foam is a modern efficient solution for raising sunken concrete slabs. Unlike traditional methods such as mudjacking, which require heavy equipment, large drill holes, and heavy cement grout that may shrink and crack over time, this innovative process utilizes advanced materials and tools to deliver superior results with less disruption. The process begins with drilling small 3/8-inch holes in the slab at strategic locations based on the injection port size. High-strength polyurethane foam, such as Alchemy, Spetex AP Lift 430, is then injected beneath the slab. This two-component foam expands as it cures, generating enough controlled force to lift the slab back into its original position with remarkable precision, up to 1/8 of an inch. This technique works effectively in both wet and dry conditions. The entire procedure is simple, clean, and efficient. After the slab is raised, the holes are patched, and cracks and joints are sealed with silicone sealants. The surface of the slab is restored to optimal condition, and crews ensure the site is thoroughly cleaned before departure. Depending on the size and condition of the slab, the process can often be completed in just a few hours. Once the repair is finished, the leveled concrete is typically ready for use in as little as 45 minutes. Commercial installation of a snowmelt system for heated driveways. The installation of a snowmelt system is a comprehensive process that transforms a driveway into a winter-proof surface, capable of staying snow and ice-free. The process begins with removing the old asphalt to prepare the surface for the new system. Once the old layer is skimmed off, the ground is leveled, compacted, and graded with gravel to provide a stable base. Trenches are also dug for the conduits that carry electrical connections to power the heating cables. Next, a binder coat of asphalt is applied, which acts as the first layer to embed the heating cables. The cables are laid on top of the binder coat, and a second layer of asphalt is applied over them. This ensures the cables are securely embedded while protecting them from damage. The installation includes placing sensors to regulate the system. These sensors detect both temperature and precipitation, ensuring the system activates only when needed. A separate over-temperature sensor monitors the surface temperature to prevent overheating. Clear the area by removing grass, roots, and excess soil thoroughly. Compact the soil using a hand tamper or mechanical tamper. This step creates a stable, firm foundation for your pool, preventing uneven settling and ensuring the pool structure remains level over time. Spread a 2 to 3 inch layer of crushed stone evenly over the excavated area. This layer provides a stable, well-drained base for the pool, reducing the risk of shifting or water accumulation. Use a sturdy garden rake to evenly distribute the crushed stone across the excavated area. Focus on filling in low spots and spreading excess material from higher areas. Work systematically, moving in rows or sections to achieve a uniform surface. Ensuring the crushed stone is fairly flat at this stage makes leveling and tamping much easier in subsequent steps. Place a long, straight board, such as a 2x4, on the crushed stone, spanning the area to act as a guide. Position a bubble level on top of the board to check for evenness. Adjust the stone by adding more material to low spots or redistributing it from high areas. Move the board systematically across the surface, repeating this process until the crushed stone base is completely level and uniform. Tamping the crushed stone is a critical step to ensure a firm and stable base for your above-ground pool. Begin by using a hand tamper or a mechanical plate compactor, available at most hardware or rental stores. Start tamping at one corner of the prepared area, working methodically across the entire surface. Apply steady, even pressure with the tamper to compact the crushed stone tightly, eliminating air pockets and reducing future settling. Focus particularly on areas around the edges, as these will bear significant weight and need extra stability. After tamping, inspect the surface for any uneven spots or loose material. Use a long board and a bubble level to thoroughly recheck the base, ensuring all areas are perfectly level. Adjust any uneven spots by adding or removing crushed stone, then retamp as needed. Lay out the pool's feet and bottom rails according to the manufacturer's instructions. Align them around the perimeter of the prepared base, ensuring proper spacing and placement for the pool's structure. Verify that each foot is securely positioned and that the bottom rails form a continuous, even circle or oval, depending on the pool's shape. Use a measuring tape and the pool's guide to mark precise spots for each foot, ensuring accurate spacing and alignment. Ensure the crushed stone layer is consistently level and at the correct height by measuring and adjusting any uneven areas carefully. Spread a thin, even layer of sand over the crushed stone, ensuring it covers the entire base for smoothness and protection. Unroll the pool walls carefully, starting from one end and gradually working around the entire perimeter. It's important to handle the wall gently to avoid any creases or damage. As you unroll the wall, ensure it is aligned with the bottom rails that you previously set up. The wall should be positioned so the bottom edge rests securely inside the bottom rails. Work with a partner if possible, to ensure the wall is evenly distributed and fits snugly into the rails. As you lower the wall, be sure it follows the curve of the pool's shape, whether round or oval. Keep the wall taut but not overly tight, allowing for a slight flexibility to adjust. Once the wall is in place, check that it is flush with the ground and forms a perfect circle or oval. Install the pool's vertical support legs by attaching them to the base rails, following the manufacturer's instructions. Ensure each leg is securely fastened and stands upright, maintaining an even height. Double-check alignment and adjust if necessary to ensure proper support for the pool structure. Use sand around the pool's base to provide extra stability and cushioning. Spread a thin layer over the prepared area before installing the liner, ensuring it's smooth and free from lumps or debris. Carefully place the pool liner inside, ensuring it fits snugly. Drape it evenly over the sides, smoothing out wrinkles as you go. Smooth out any wrinkles in the liner by gently pulling and adjusting it. Work from the center outward. Once wrinkles are minimized, install the coping along the top edge to secure the liner and finish the pool. Priming involves evenly rolling a 0.2 kilograms per square meter layer of poo binder onto a clean, dry cement base for strong adhesion. Mixing requires combining SBR rubber granules and PU binder in an 8:1 weight ratio. Thoroughly mix until the binder fully coats the granules, ensuring a uniform, adhesive mixture for the base layer. The key to successfully paving the SBR layer is ensuring proper compaction. After spreading the SBR and PU binder mixture evenly across the primed surface, use a trowel or roller to compact the material firmly. This step eliminates air pockets, creating a dense, solid base that enhances durability and prevents surface deformation over time. Accurately draw the design lines on the compacted SBR layer using chalk or stencils. Precise markings ensure the EPDM rubber colors are applied neatly, maintaining the intended pattern and visual appeal. The surface pattern's quality relies heavily on accurately drawn lines. These lines act as guides for applying the colorful EPDM rubber granules, ensuring that each segment aligns perfectly with the design. Inaccurate or uneven lines can lead to irregular edges, mismatched patterns, and a less polished finish. Using stencils or measuring tools for precision helps maintain sharp, well-defined boundaries between colors. resulting in a visually appealing and professional-looking playground surface. Mix EPDM rubber granules and PU binder at a 6:1 weight ratio. Ensure thorough mixing for 6 to 8 minutes until the binder uniformly coats the granules, creating a cohesive, workable material. To infill the colorful EPDM rubber, carefully follow the design lines drawn on the SBR base layer. Begin by mixing the EPDM granules and PU binder thoroughly to ensure a smooth, adhesive consistency. Use a trowel to apply the mixture precisely within the marked lines, starting with one color at a time to avoid overlapping. Work methodically, pressing the EPDM mixture gently but firmly into the surface to eliminate air gaps and ensure uniform coverage. Pay close attention to edges, as they should be clean and sharp to maintain the integrity of the design. Continue filling all segments of the design, transitioning between colors as needed while keeping edges distinct. Ensure each color's edge is neatly defined and smoothly finished by using precise tools like trowels and stencils. Sharp, clean edges enhance design clarity and prevent colors from blending or overlapping. Achieving a smooth, radian, and horizontal surface ensures safety, aesthetic appeal, and durability. Carefully trowel to create gentle curves and even levels, minimizing trip hazards and providing a seamless, visually pleasing finish. Covering EPDM rubber on vertical planes requires precision and expertise. Apply the mixture evenly, pressing firmly to prevent sagging. Work in small sections, smoothing meticulously to maintain adherence and a consistent professional appearance. Mix EPDM granules with PU binder for 6 to 8 minutes for even coating. Regular stirring takes just 1 minute. Maintaining a thickness of 6 to 10 millimeters for the EPDM rubber layer is crucial for both durability and safety. This range provides sufficient cushioning to absorb impact while ensuring the surface remains robust and resistant to wear. Use a calibrated tool, such as a depth gauge or screed bar, to measure and maintain uniform thickness throughout the application. Variations in thickness can result in uneven surfaces, reducing aesthetic appeal and potentially creating safety hazards. Pay extra attention to corners, edges, and transitions between colors, as these areas are prone to inconsistencies. For high-impact zones, consider maintaining the upper limit of 10 millimeters for enhanced protection. Regular checks during application will help achieve a smooth, level finish that meets safety standards. Creating smooth radians and horizontal surfaces ensures seamless transitions, enhances safety, prevents tripping. Once the EPDM rubber surface is fully cured, painting lines, letters, and patterns as per the design adds the final touch. Use high-quality, durable paint suitable for rubber surfaces to ensure longevity. Carefully apply the paint with precision, following the design lines that were previously marked. Consider using stencils for accuracy, especially for intricate patterns or text. Allow the paint to dry thoroughly before allowing use, ensuring vibrant, sharp details that enhance the aesthetic appeal and functionality of the playground. Stone carpets like Nature Stone offer a durable, attractive, and practical flooring solution, especially for outdoor spaces. This installation guide provides a step-by-step process for laying a stone carpet in an exterior setting, ensuring a professional and lasting result. Start by preparing the surface where the stone carpet will be applied. The base should be stable, clean, and free of cracks or loose debris. Suitable surfaces include concrete screed or other solid materials. Clean the area thoroughly to remove dust, oil, or contaminants. If there are cracks or irregularities, repair them to ensure an even surface. Apply a primer to enhance adhesion between the base and the stone carpet material. Nature stone carpets consist of natural stones or aggregates mixed with a special resin binder. In a clean container, combine the resin with the stones as instructed by the manufacturer. Mix thoroughly until all the stones are evenly coated. Ensure the mixture is prepared in small batches to prevent the resin from hardening before application. Once mixed, pour the stone resin mixture onto the prepared surface. Using a trowel, spread the material evenly to the desired thickness. For exterior applications, a thickness of 10 to 15 millimeters is typically recommended for durability. Work quickly and methodically to prevent the resin from curing before the area is finished. Smooth the surface with the trowel, ensuring an even and compact finish. Allow the stone carpet to cure for at least 24 to 48 hours depending on the temperature and humidity. Avoid walking on the surface during this time. Once cured, the stone carpet will be robust and ready for use. For added protection, a transparent sealing layer can be applied, enhancing durability and resistance to stains and UV damage. Road rehabilitation on the A96, a high-tech endeavor in the far south of Germany, near Lindau at Lake Constance. A critical road rehabilitation project is underway on the A96. Spanning over 6.8 kilometers, this initiative aims to install both the base and binder layers of a new road surface, ensuring smoother, safer travel for commuters. To facilitate this large-scale project, traffic has been rerouted to the opposite lane, allowing for uninterrupted work on the designated stretch. At the heart of this project is the Vogel Super 3000-3i, the world's largest road paver. Renowned for its advanced capabilities and efficiency, this powerhouse machine offers maximum paving capacity, 1,800 tons per hour maximum paving width, 18 meters maximum layer thickness, 50 centimeters. These impressive specifications not only streamline construction, but also set a new standard in road building technology. The cutter Geomembrane Co. KG, a well-established construction firm based in Memmingen, recognized the Super 3000-3i as the ideal tool for the job, particularly given its need for precise and efficient performance. A critical challenge in this project is the seamless installation of both layers across a width of 12 meters, achieving maximum flatness and pre-compaction. The Super 3000-3i rises to the occasion, thanks to its state-of-the-art Vogel Screed SP350. This advanced screed, with a base width of 3.5 meters, delivers exceptional flatness due to its rigid reinforcements. In its high compaction version, it features tamper bars and pressure bars, which ensure optimal pre-compaction during paving. These features make it a perfect choice for demanding projects like the A96 rehabilitation. The Super 3000-3i is equipped with several cutting-edge features to optimize its performance. Among them is the hydraulic tamper adjustment, which allows operators to adjust the tamper settings to 4 or 8 millimeters with the push of a button. For this project, the high compaction screed required only 4 millimeters tamping to lay the 14 centimeter thick base layer, demonstrating the efficiency of this advanced technology. To maintain a continuous workflow, the Super 3000-3i is supplied by two Montana 3000-2 offset power feeders, operating in parallel. These feeders, in turn, are restocked by trucks in a staggered fashion, ensuring there are no delays or waiting times. This meticulous coordination allowed up to 4,000 tons of material to be laid daily, with minimal dust emission. The machine's Ergo Plus 3 operator platform enhances the operator's control and visibility, making the complex task of road paving more manageable. Furthermore, the project utilizes the two-way multiplex ski system, which automatically detects and corrects surface irregularities, ensuring a perfectly even base for subsequent layers. The driving force behind the Super 3000-3i is a robust 6-cylinder diesel engine, generating 354 kilowatts of power. However, for this project, the machine operated in eco mode, delivering fuel efficiency and reduced noise levels while maintaining performance. In compliance with the stringent Stage 5 emissions standards, the machine also features the Eco Plus emissions reduction package, which makes it cleaner, quieter, and more efficient than required by regulations. This innovation underscores Vogel's commitment to sustainability and cutting-edge engineering. As the flagship model of Joseph Vogel AG, the Super 3000-3i represents the pinnacle of modern road construction technology. Combining superior engineering with advanced innovations, it is setting new benchmarks for efficiency, precision, and environmental responsibility. The AGUSS Trigona Bitaplan roll-in cable shaft cover is an innovative solution for modern infrastructure needs. Designed to support applications such as fiber optic cables, district heating systems, and signaling infrastructure. Developed by AGUSS, part of the ACO Group, this shaft cover system consists of three main components: a frame, a lid, and an adapter frame. The adapter frame is positioned in the recess. The inner edge of the frame is sealed with moist sand to prevent any leakage during installation. Once in place, the frame is securely fixed using shaft grout mortar, ensuring it remains stable and aligned. A bonding agent is applied to the surrounding area of the recess. This step is critical to achieve a secure bond between the adapter frame and the asphalt layer to be installed. The reusable installation mold is prepared by coating it with a release agent, which ensures easy removal later. The mold is then positioned within the adapter frame, creating a precise cavity for the asphalt application. Asphalt is spread evenly over the recess and compacted thoroughly to create a strong, even surface. A bonding agent and a bituminous band are applied to ensure a seamless and watertight joint with the existing pavement. After the final layer of asphalt is slightly overfilled, the installation mold is carefully removed. This must be done promptly to allow the next steps to proceed smoothly. The frame is immediately positioned and the covers are installed securely. The edges of the asphalt are compacted around the frame for better sealing. The surface is then moistened, and the cover is vibrated into place to ensure a perfect fit. Once installation is complete, the shaft cover is inspected for proper seating and functionality. The covers are opened to verify that the locking mechanism operates correctly. The JCB3CX is a versatile and powerful backhoe loader widely recognized for its efficiency in construction, landscaping, and utility work. Manufactured by the British company JCB, the 3CX is renowned for its robust design, fuel efficiency, and adaptability to a wide range of attachments. It features a powerful engine, advanced hydraulics, and operator-friendly controls, making it ideal for tasks such as digging, trenching, lifting, and loading. With its ability to switch between front loader and backhoe functions seamlessly, the JCB3CX is a staple machine on construction sites worldwide. When paired with attachments like the RAF MZB 600 mixing bucket, the JCB3CX becomes even more versatile. The RAF MZB 600 is a specialized concrete mixer bucket designed for efficiently mixing and transporting concrete or mortar directly to the required location. With a capacity of approximately 600 liters, this attachment is particularly valuable for projects that require precise and timely delivery of mixed materials in challenging or confined spaces. Its hydraulic mixing system ensures even consistency of the mixture, while its robust build and easy-to-operate discharge mechanism enhance durability and usability. This combination of the JCB3CX and the MZB 600 mixing bucket significantly enhances construction productivity by eliminating the need for separate concrete mixing equipment. The integrated setup allows operators to mix and pour concrete directly on-site, reducing labor costs and time. Such efficiency is especially beneficial in remote or compact work sites where traditional concrete mixers may not be practical. Microsurfacing lowers carbon footprints by using cold-applied techniques, reducing energy-intensive processes, emissions, and waste, promoting sustainability. Microsurfacing achieves up to 50% energy savings compared to traditional plane out and inlay methods by eliminating the need for energy-intensive processes such as heating materials or extensive excavation and transportation of waste. The cold-applied technique minimizes fuel consumption during application, significantly reducing energy demands. Additionally, the in-situ mixing of materials further reduces the carbon footprint associated with material production and logistics. Microsurfacing effectively fills ruts and deformations up to 40 millimeters, restoring road surfaces to their original profile. The process rejuvenates fretted macadam carpets by sealing cracks and voids, enhancing structural integrity and skid resistance. Microsurfacing carriageway process. A sustainable solution, microsurfacing, offered by colas, is an innovative and sustainable carriageway treatment that serves as a low-carbon alternative to traditional road resurfacing methods. By employing a cold-applied process, it significantly reduces energy consumption, emissions, and waste outputs, enabling clients to lower their carbon footprint by as much as 50% compared to conventional plane-out and inlay techniques. The process involves mixing materials on-site and applying them directly to the road surface, minimizing preparation needs. Loose debris is swept, street furniture protected, and gullies covered to prevent water contamination. The range of materials available enables the treatment of various surface defects, including wheel tracking, potholes, and failing concrete or macadam overlays, restoring up to 40 millimeters of rutting or deformation. Colas utilizes a comprehensive one-stop shop approach, working closely with local authorities to inspect, design, and implement practical and cost-effective solutions. With a diverse fleet of machinery ranging from 2 to 12 cubic meters and in-house manufacturing of bituminous emulsion, Colas maintains full control over quality and composition. The installation of geotextile involves preparing a smooth, clean surface, unrolling the fabric with proper alignment, ensuring overlaps between sections. The installation of GCL involves unrolling the material over the prepared surface, ensuring full coverage with minimal overlap, and securing it in place to form an impermeable barrier, enhancing fluid containment and stability. Following the installation of the GCL, the geomembrane is installed to provide an additional impermeable barrier. Geomembranes are typically made from high-density polyethylene, HDPE, or other synthetic materials, and they are essential for providing a waterproof seal in various engineering applications. The geomembrane is carefully rolled out over the GCL, with the edges overlapping to ensure a continuous barrier. It is crucial that the geomembrane is installed with minimal tension and that any wrinkles are smoothed out, as wrinkles can create pathways for leaks. Fusion welding is a crucial technique used to join geomembrane sheets, ensuring a seamless and strong bond. During the process, the edges of the geomembrane are heated to a specific temperature using hot air or a welding tool, causing the material to soften and become pliable. The softened edges are then pressed together with a specialized roller or clamp, creating a uniform, durable bond once cooled. Fusion welding provides a highly effective and waterproof seal, preventing leakage and ensuring the integrity of the barrier. This method is commonly used for high-density polyethylene HDPE geomembranes and is essential for applications like landfill liners and containment ponds. Precision and proper equipment are critical for successful fusion welding to ensure long-term performance. Extrusion welding is another method used to bond geomembrane sections. In this process, a welding machine extrudes a molten plastic material along the seam of the geomembrane, which is then fused with the edges of the sheets to form a continuous waterproof seal. Extrusion welding is often used in areas where fusion welding is not feasible, or where extra reinforcement is needed at the seams. The Baraba Brick Stone Paving Machine is a cutting-edge piece of equipment designed to streamline the process of laying paving stones efficiently and accurately. This machine is especially useful in construction and landscaping projects where large-scale pavement installation is required, such as roads, driveways, parking lots, and pathways. What sets the Baraba paving machine apart from traditional methods is its ability to automate much of the manual labor involved in the paving process. The machine operates with precision, placing each brick or stone in the desired pattern with minimal human intervention. This ensures that the paving work is not only faster but also more consistent in quality, reducing the margin for error that is common when relying solely on manual labor. The Baraba Brick Stone Paving Machine features advanced technology, including adjustable settings to accommodate various sizes and types of paving stones. This flexibility makes it suitable for a wide range of projects, whether you're working with small decorative stones or larger heavy-duty bricks. The machine's design emphasizes durability and efficiency, capable of handling tough outdoor conditions and extended hours of operation. In addition to its performance, the Baraba paving machine is known for its user-friendly interface, making it accessible to both seasoned professionals and those new to the industry. With easy-to-follow controls and safety features built in, the machine helps to reduce risks on the job site, contributing to a safer and more productive working environment. THB, one of the UK's leading surfacing contractors, has been at the forefront of enhancing road safety and infrastructure through a series of initiatives, including the installation of new pedestrian crossings and extensive road resurfacing projects. Known for their expertise and commitment to quality, THB has made significant strides in ensuring safer and smoother roadways for both pedestrians and motorists across the country. The installation of new pedestrian crossings is a key aspect of THB's efforts to improve road safety in urban and rural areas alike. By focusing on high-footfall locations, the crossings aim to provide safer passage for pedestrians, especially in busy traffic zones. Whether in city centers or near schools and public transport hubs, these crossings offer enhanced visibility and accessibility, with added features such as improved lighting, tactile paving, and advanced signaling systems. The design and installation process are carried out with careful attention to local traffic conditions, pedestrian needs, and overall traffic flow, ensuring minimal disruption to daily life while improving pedestrian safety. In addition to pedestrian crossings, THB's road resurfacing projects play a crucial role in maintaining and upgrading the UK's road network. Road resurfacing is vital for prolonging the lifespan of roads, improving driving comfort, and enhancing safety. Whether it involves major highways or smaller local roads, THB's team utilizes the latest technologies and materials to deliver high-quality resurfacing solutions that stand up to the challenges of heavy traffic, adverse weather conditions, and wear over time. THB's approach to road resurfacing is methodical, incorporating state-of-the-art equipment and skilled teams who can quickly and efficiently complete resurfacing tasks with minimal disruption to motorists. By using durable materials such as hot-rolled asphalt, surface dressing, and microsurfacing, THB ensures that roads are not only smoother and safer but also more resistant to damage in the long run. The resurfacing process helps reduce maintenance costs in the future while boosting road safety by eliminating hazards like potholes and uneven surfaces. Chip seal with fabric is a highly effective pavement preservation method used to extend the life of roads. In Cecil County, Maryland, this technique was employed as a cost-efficient solution to improve road conditions and enhance the durability of the pavement. The process begins with the application of a fabric layer onto the existing asphalt surface. This fabric acts as a barrier, preventing moisture from penetrating the pavement structure, which can lead to deterioration. Once the fabric is laid down, a layer of hot asphalt binder is applied over it, followed by the placement of aggregates, small stones or gravel. The aggregate is then compacted into the binder, creating a durable, skid-resistant surface. In the case of the double-shot chip seal used in Cecil County, 2 layers of aggregate were applied, enhancing the road's resilience. The first shot of aggregate is applied and compacted, and then a second layer is added to ensure a thicker, stronger surface. This process helps to improve the road's ability to withstand traffic loads, weather conditions, and general wear and tear over time. Chip seal with fabric is particularly beneficial for extending the useful life of older roads without the need for expensive full-scale repaving projects. At Heath Farm in Norwich, a groundbreaking method for laying curbs has been introduced, revolutionizing the construction process. This approach employs an ingenious machine designed to lay curbs with remarkable speed and precision, drastically reducing the time and effort required for manual labor. The machine's advanced technology allows for the automatic placement and positioning of curbs along the desired path, with minimal human intervention. The key advantage of this method is its ultra-fast execution. Traditional methods of curb laying often involve extensive manual labor, where workers must manually move and position each curb stone. This process can be time-consuming and physically demanding. However, with the use of this machine, the job is completed in a fraction of the time, significantly increasing efficiency on site. The Stormtrap system is an innovative and efficient solution designed to manage stormwater runoff through detention, infiltration, and harvesting. It plays a critical role in sustainable urban drainage systems by helping to mitigate the impact of heavy rainfall on both the environment and infrastructure. By providing storage and controlled release of stormwater, the system reduces the risk of flooding, enhances water quality, and promotes water conservation. In a forward-thinking project, 6 Stormtrap detention and infiltration systems were chosen for their ability to manage and treat stormwater in a highly efficient and environmentally friendly manner. A hallmark of the Stormtrap system is its modular design, which offers flexibility to meet varying project demands. Each module can be customized to fit the specific size and design requirements of a site, making it suitable for a wide range of applications, including urban developments, transportation hubs, and industrial sites. These modules are made from durable, high-strength concrete that ensures longevity and reliability. The system's design allows for both detention and infiltration, meaning it can store rainwater temporarily and then gradually release it into the ground, replenishing the local water table. The project selected for this implementation involved the installation of 6 Stormtrap systems, totaling a storage volume of 2,196 cubic meters. This volume is critical in managing large volumes of stormwater generated during heavy rainfall, which otherwise could overwhelm traditional drainage systems. The combination of detention and infiltration capabilities allows for the effective management of stormwater while maintaining the natural hydrological balance of the surrounding area. In addition to the detention and infiltration systems, the project also incorporated a stormwater harvesting system, a key component in sustainable water management. The harvested rainwater can be redirected for non-potable uses such as irrigation, landscaping, and even cooling systems. This further reduces the demand on potable water supplies and contributes to the overall conservation efforts of the facility. The installation of the Stormtrap system was completed in just 6 days, showcasing its efficient construction and minimal disruption to the surrounding environment. The foundation of the system is built on compacted aggregate, ensuring a stable base that can support the weight and functionality of the modules. Drilling out inside driven steel tube piles is a common technique used in foundation construction when refusal is encountered above the design towed level, preventing further penetration. Refusal refers to the point where the pile is no longer able to progress due to high resistance from underlying soil or rock, often before reaching the intended depth. When this occurs, it is necessary to address the situation to ensure the pile reaches the designed bearing capacity and depth. To overcome refusal, drilling inside the tube pile is typically employed. This involves using a drilling rig or auger to bore into the soil or rock at the base of the pile, which allows for the removal of material and reduces the resistance encountered by the pile. The purpose is to create a more favorable condition for redriving the pile to the desired depth, ensuring the pile achieves its designed bearing capacity. The drilling process usually begins with the insertion of a drill bit or auger inside the steel tube pile, which is lowered to the point of refusal. Once in position, drilling proceeds to remove soil, gravel, or rock, creating a path for the pile to penetrate deeper. Depending on the geotechnical conditions, this can be done in stages to prevent excessive material buildup. After drilling, the steel tube pile can be redriven with a pile driver or hammer to continue its progression down to the designed depth or refusal level. This process allows the pile to bypass obstructions or tough layers of soil and rock, ensuring the foundation design is met. Drilling out also helps to ensure that the pile remains structurally sound, minimizing the risk of damaging the steel tube during redriving.